Hi, my name is Tyler, and I'm a graduate student researcher at UC Santa Cruz. And today I'm going to tell you a little bit about cell size control. So, normally, cells of a particular type maintain tight control of their size. For example, even though in humans, cells range across many orders of magnitude, however, cells of a particular type maintain tight control of their size, as depicted in this cartoon. And it turns out that a loss of size control is a nearly universal feature of cancer. So here what we're looking at are cervical epithelial cells. And what we can see is that cell size becomes increasingly dysregulated as cells become increasingly oncogenic. And this brings up an important question of how and why do cancer cells lack proper size control? To begin to address this question, I chose to focus on the prominent oncogene RAS. RAS is a family of GTPases, which means that its signaling is active only when bound to GTP. And following GTP hydrolysis, RAS signaling is turned off. It turns out that mutations in RAS, which result in hyperactive signaling, are frequently found in cancer. So to begin my investigations, I first sought to determine if hyperactive RAS signaling modulates cell size. And to do this, I directly measured cell size using a Coulter counter. What I found is that hyperactive RAS increases cell size in both mammalian cells on the left and in budding yeast, the panel on the right. Now, I next aimed to define some of the molecular mechanisms underlying how RAS could be influencing size control. To do this, I chose to initially investigate how hyperactive RAS may be influencing cell cycle progression relative to growth and size checkpoints, because we know that growth and size checkpoints control cell cycle transitions. One of them being the G1 to S transition, which is controlled by the G1 cyclins depicted here in blue and in green. What I found is that expression of hyperactive RAS seems to decouple early G1 cyclins from late G1 cyclins. So here we're looking at a Western blot, and what we can appreciate is that hyperactive RAS is increasing the early G1 cyclin CLIN3. However, it's decreasing and delaying expression of the late G1 cyclins CLIN2. Now, this is an interesting and somewhat unexpected finding because it's thought that RAS signaling promotes cell cycle progression. And it's known that G1 cyclins are coordinating expression and promoting cell cycle entry via this feed-forward mechanism. However, when RAS signaling is uncontrolled and hyperactive, it seems that the coordination is broken. And with that, I would like to thank ARCS, and I would like to thank you all for stopping by my poster. Thank you.